everyone. Monday night, it is the physicist and philosopher, the physicist being Dr. Claudia Albers. Hello, Claudia.
Hello.
And myself, R. Wayne Steiger, as the philosopher. So, Claudia, how have you been?
Yeah, I've been well. I've been doing quite a bit of writing and the usual thing, the writing and
the writing
about it. And
thinking is what most people don't realize. And my wife, where she is the chief medical officer, deals with a lot of elderly people. And it's quite what I look when I hear her stories is that the ones that have youth, even in their 80s, are the ones who think, the ones who write, the ones, and the others, of which there are far more of those, are basically slowly losing their memories. So writing is a healthy thing. Thinking outside the box is even better.
Yes.
So other than that, what else has been going on?
Well, not much. We had some live stream with Jeff P. And the Boogeyman and all of us together this weekend. It was all about because Jeff P got attacked by another channel, and he said he would attack me as well, but so far he hasn't made a video. But basically, it's just saying that Jeff P's photographs were just lens flares and things like that. And obviously, and Jeff P made a very good response video where he showed clearly that he's showing real things, which is the lens array and real objects in the sky. So
Jeff has been at this for a while, and it never ceases to amaze me that it goes in cycles. You see these people who come up and think that they're doing humanity a great disservice by attacking. And you and I both know that Jeff P has been at this for a very long time.
Yeah, very long time indeed.
And I often say that there are many pros and cons about a social media platform such as YouTube. One of the positives of what I see is that it's also a video history of the individual. And if you don't see any deviation in the individual after year after year after year, that at least says several things to me: consistency, integrity, and that isn't a bad thing.
Yeah.
So that's just my take. Hello, everyone.
Right. No, he does really good work, and he
does
integrity. Absolutely, yeah.
Yeah, there's a lot of hours that he puts into that. So my hat's off to him. Just want to say hello to everyone in the chat room, to all the moderators. Hello, hello, hello. So, Claudia, we've had a very interesting week. I want to address, I think specifically, as we get started here, the events that happened on Friday. Now, here in the United States, it was basically a frenzy of the whole thing called hate, which is under the guise of politics. So here is a make-believe situation that's going on in America, and not one news station, not one, Claudia, did any type of coverage of this event. This was the earthquake that hit over in Indonesia. So what I did, Claudia, is that I went back and started pulling up the headlines from what happened, and how this was not brought out. It was a disaster. So on Friday, we see that the earthquake happened. Now, I wasn't aware of this. Do you know how big the wave was, the tsunami?
No, how?
18 feet.
Oh my goodness, 18 feet.
18 feet. And I'm going to show you how this
Wow.
thing, that they completely missed it. Here you go. This was then Saturday. And you can see now Reuters is covering this. And tsunami kills hundreds. This is what it was at that time. At that, they were still, because they could not measure it, because apparently all of the sensors missed this, the way that it formed. And when I'm going to show you how this city that really got hit the hardest, it was remarkable. They were a sitting bullseye to begin with. So here we got 540. Death toll could be 1,000. And then we begin to get reports like this today, that what was happening, the ground was liquefying.
Oh my goodness.
And here we have a number of pictures. The person sitting on this building here thought he was safe as he's watching all the ground around him and buildings floating by as the ground was liquefying. Here you can see it here. And of course, these people had nowhere to go.
Oh my goodness.
It was the fact that not only was the tsunami, and you can see how it just picked up. I have one picture here.
Oh my goodness.
You're going to absolutely look at the size of this boat.
Wow.
And this boat, by the way, Claudia, is sitting about 15 feet out of the water.
Yes.
So we're going to see. So here it was, a 7.5, and here you can see why I think it's Pula got hit so bad, Claudia. Look at this. These folks were in a channel. This earthquake was right over here, and so they got the intensity of the shock wave of the tsunami, and I think it may be why the sensors didn't pick it up. But when it got channeled in here, these people didn't have a prayer. And you can begin to see the scale and the scope of the damage. So the area was very large, but very specific. You can see that other homes.
Look at that. That's amazing. The devastation.
Yes. And this is ground that liquefied. They didn't have a chance in any of this. So the earth is changing here. Here you can see the effect of it as well. And before we went live, they have had, I've gotten 4 alerts of the aftershocks going in the same area. So there you go.
My goodness.
It is kind of sad, isn't it?
It's very sad.
And, you know, it's one of those things that we're seeing more and more earthquakes, aren't we? They seem to be showing up more and more.
Yeah, definitely. And
I'm just going to close some of my windows out here. So I brought that up because it tells me, and because this is going to lead into the next story that I thought you and I would talk about, that we're seeing things happening in our earth. Now, I remember back in 2014, 15, when CERN was firing up and people were covering that. We were seeing the inordinate amount of electricity that was being required to generate the large Hadron Collider. And we were beginning stories that they were reaching intensities of heat that were surpassing our star. And we also heard that they were, because of the experimentation that they were doing, that there were maybe potential effects hitting our magnetopause and maybe subsequently hitting as well particles deep in our Earth. And I remember that being covered quite well. So here's the thing. I sent you the article, and I know you wrote something on this. And give me 1 second as I pull it up. Here we go, because it's been getting a lot of coverage. I think, Claudia, it's going to get a lot more.
Yes, the cosmic rays.
Yes, the cosmic rays emitting.
Yeah, this is Anita, the balloon experiment. So they have these detectors, they radio wave detectors, and they pull it up to an altitude of 35 kilometers above the ice sheet in Antarctica.
Now, is this the unit they send up, Claudia?
Yes.
That is enormous.
It is enormous.
Wow.
Yeah.
Now, is this tracking neutrinos? Is this tracking heavy particles?
It doesn't actually pick up neutrinos. It picks up radio pulsars, which occur when the neutrino interacts with the ice sheet. So it detects neutrinos that interact with the ice.
Okay.
And then from the direction from which the radio pulse came, they can figure out where the neutrino came from.
Oh.
But the neutrino is actually a secondary particle. The primary particle are extremely high energy cosmic rays, primary particles. That would be something like protons or one of the mesons, you know, the pion, the muon, and things like that. There's also a tau meson, that's the heaviest one, that would produce a very fast-moving neutrino. So these are extremely fast-moving particles. The neutrino will be extremely fast-moving, moving very close to the speed of light, and the primary particles as well that gave rise to the neutrino.
Okay, and what I'm going to do, I'm going to pull up the paper that you wrote on this. And so give me 1 second as I pull this up, because what I guess I am understanding, and I'm looking to you as the teacher here. So they're finding that the Earth is emitting cosmic rays?
Yeah, so what happened was Anita detected all these cosmic rays. Some of them were coming from space. They only expected to find cosmic rays coming from space, even coming from below, but from above the horizon, perhaps. But it found that some were coming at such an angle that they had to be coming from the ground. So that meant that they had to come from within the Earth. So the astrophysicists wrote a paper saying basically the only way we could have such high energy neutrinos coming from the Earth is if they are created by primary particles that came into the Earth on the other side and went right through the Earth. The problem with that is that the standard model forbids any particle that is part of the model from being able to do that. None of the particles that are characterized by the standard model. The standard model is basically a way of keeping track of all the particles.
And that is what physics is built upon, right? Is the standard model.
Yeah, particle physics.
Yeah,
and astrophysics as well, because they use it as well. So basically they said that it must be a particle that's outside of the standard model. So what usually occurs after that, these are the astrophysicists speaking, it's the particle physicists that are responsible for modifying the model. So then the particle physicist will have to go and modify the model. And my whole thing is none of them would even cross their minds to suggest that these particles are actually coming or being emitted by the Earth, that the Earth is the source. And the reason for that is because they will not consider any of the observations that we've been looking at, that I've been looking at, and that is of the stellar cores in the sun's corona, and the fact that they show that stars and planets are very much alike. They have cores, they emit light from their atmospheres. The basic difference between a star and a planet is size. A star is much larger, so has a lot more energy, so produces a lot more light from its atmosphere, and has all kinds of other things that it can do because of that very high electric field in its atmosphere. But because of the observations I've been doing, I know this, so I know it's very likely that the Earth is actually producing these cosmic rays. It's emitting them. And that is because the Earth, the source of it has a source of energy just like a star, and it's in its core. And so it is able to generate energy. And then with the stellar core matter, it actually pulls energy. We know it was pulling energy from the sun. That's why the sun became so much more active for so many years. And then they are able to pull it from planets as well. So it's likely that there's a lot more energy generation from the Earth because of this, because the stellar cores are pulling energy from the core of the Earth.
Okay, I'm processing, and I've read this article. And thank you for writing an article on this, because I'm trying to then rationalize in my mind, then if we're detecting this on Earth, and let's say I'm going to put 3 different buckets up for us. Bucket A is that our planet has been doing this since it was formed. Bucket B would be that there is something that has caused this to happen, and it could be cosmologically early, very recent. Or C, something artificial is happening. Now, if we take bucket A, that this is something that the planet has done naturally all along, and we have somehow missed this, then my question, Dr. Albers, would be, then would we see the same particular phenomenon on the other planets?
Yes, most likely.
Interesting.
Mm-hmm.
Wow.
Yeah, so all the planets will be affected by these stellar cores. I'm sure there are several that are being hosted by the other planets. Venus, we already talked about Venus the last time. I'm sure there's at least a large one there. And yeah, Mars, I'm sure.
And I'm thinking now Jupiter and Saturn. I mean,
Jupiter will have lots of them. So will Saturn.
Claudia, I'm thinking about this, and I don't know of any detectors that have been out there, but this could potentially would have to open up a whole new area to be researched.
Yeah, because the solar system is a source of ultra high energy cosmic rays. They're coming from the planets and the sun. We don't even need a source outside of the solar system, because now all the planets become sources.
And I can't see the chat room, but this is hitting me, and I'm going, again, we're discovering new things about our freaking planet that we've been here how long, but is that now that if this is potentially as well being emitted, someone like Jupiter, Saturn, I mean, this could be having a health effects on Earth and subsequent space weather as well. Could play havoc with our magnetopause.
Well, cosmic ray, yeah, I suppose so. But what happens with the magnetosphere is a huge quantity of not such high energy. These very high energy particles are not in the same kind of numbers that we would get from the solar particles that, in the solar wind. We get many, many more. So But because they are such high energy particles, they are very damaging to anything that they impact, especially
Yeah.
with tissue.
Wow.
So and if they coming from the Earth, I mean, there's really no escape.
So do you think that our experimentations with, large colliders like CERN, there's other colliders around the globe, other countries have them. Could this be playing a role, do you think? I mean, it's
I don't think so, to tell
okay.
you. I don't think the particles that are colliding and generating a whole stream of other particles that come out of those reactions, I don't think there are that many. I don't
Okay.
think they are escaping that very high magnetic field inside the tubing
Yep.
for the collider. I don't think the particles themselves are the problem. I think there's something else going on, and that is that they're trying to break the space-time continuum with the collisions. It's space itself, because particles are contained within spatial dimensions. There's something about the particles themselves, because particles are made out of energy, but it's energy contained within a vessel. And that vessel seems to be space itself. So what they could do is rupture the space-time continuum. That's the problem.
Well, that could present a problem for all inhabitants of Earth. I mean, I don't know what the potential consequences are, but I do.
Well, I don't think black holes exist, but technically a rupture could create something like a black hole.
Yeah. Well, they used to have the thing called string theory. And, it was always the point of that in between each string of reality dimension, there was this thin membrane that separated the two.
In string theory, you have the three dimensions, space dimensions, and then you have the time dimension. And then you have a whole lot of other dimensions that are curled up. So they're not obvious in our current space-time. But when we start probing particles microscopically, then you may start getting effects from those. The thing is, string theory is very difficult because it comes up with ideas, but there's no way of actually testing them.
That's the best kind of theory, right?
Yeah.
So I want to get back on the particles, because this is what they think they've detected as a new part. So when you said that when we can actually begin to look under microscopic conditions, does the characteristic of a particle alter if the vibration of the particle is faster or is altered?
Yes. Basically a particle, it is both a point particle, or with some size, almost like a sphere, a physical sphere, and it's a wave.
Okay.
And with that wave, you're always going to get a frequency. So basically, there's always some kind of vibration associated with a particle. It's not like there's something sitting there. The particle never just sits. It's always in motion.
Always in motion.
It's always fluctuating. There's always a fluctuation associated. It's always a wave. Like I discovered that gravity is actually, it's more like a sound wave, but it's a stationary wave. But it's because there's a photon in there, and the photon is a wave. It's a traveling wave. But when you contain a photon inside a particle, it seems to become a stationary wave. So the traveling wave that the photon is becomes the gravitational wave when the photon is inside the particle. But that's suggested to me because we've always been taught that electromagnetic waves are transverse waves. And that means that if the wave is traveling horizontally, that the vibration is up and down at perpendicular to it. And the vibration is in the electric and the magnetic field associated with that photon. But because it's like a gravitation is like a sound wave, I tend to think that a photon and an electromagnetic wave may also be a longitudinal wave. And that would mean that we could actually think of it as the physical photon, which would be a sphere, and then it would be pressed, so it would become a flattened sphere, almost like a toroid on its side. And then the electromagnetic wave would be a whole lot of these squashed together. So a wave would be a whole lot of photons staggered together, you know, making a line, almost like a necklace. And then the electric and the magnetic field would be what it is at the edge of the photon. And it would produce that kind of wave pattern because the edge of the photon would be rounded like that, looking like an ellipse, and then with another one around it. So you would have that pattern anyway. But it would be all the way around. It would be a three-dimensional pattern, not the two-dimensional that we usually see for electromagnetic waves.
As you're talking, I keep on thinking on gravity, then, you know, I keep on seeing gravity would equal electric and magnetic interacting with each other to form what I would call a law of attraction. Mm-hmm. I mean, that's a layman's term, and I know that's probably not correct, but because gravity, again, gravity is not consistent. Mm-hmm. It's constant, but it's not consistent. I mean, that's what baffles me is.
Yeah, well, it has to decrease with distance from the central point of the object or the particle. It has to decrease with distance. And yeah, but it's a stationary wave and it would have to have minimums in it because it's a wave. So it's not always a maximum. I mean, it would decrease, but it would still fluctuate as you move away from the center.
So how do we account for the moon? I still don't, you know, I always thought that gravity would be the result of rotation and that rotating objects would then generate its own gravitational field. But I still don't understand the moon. I don't understand, you know, I know how they explain it.
Well, actually, it causes objects to rotate because it pulls them inwards. So if an object comes by and here's a planet, the object comes by, it's got a velocity that should keep it going in this direction if there was no planet there. But because there's a planet there, it will be deflected downwards towards the planet.
But every other moon, every other satellite
can go into orbit around that planet.
But our moon doesn't spin.
Oh, it's not about spin at all. I mean, I meant, or that's the orbit.
Okay.
It's not about spin. The spin is, as far as I know, not connected to gravity. Well, I could be wrong, but I don't see any connection between this. Well, it could be, and that is, I mean, an object could spin because of the fact that we have a minimum at the center.
Well, see, I keep on going back to the hologram. The moon doesn't make any sense. Every other satellite, every other moon in every one of the planets that's out there, even asteroids that seem to have moons around them, they all spin.
Well, the moon spins as well, but it spins at the same with the same period as its rotation.
I've never seen the backside of the moon, though.
Yeah, we don't see it, but because it spins at the same rate that it moves around. That's why we'd never see it.
I still don't get that.
Yeah, you see, the moon's moving around this way, and as it moves around, it turns slightly. You see, okay, this my microphone.
Yeah.
I don't
Yeah,
to do it this way. So if the moon is moving this way,
yeah,
if it didn't spin, it would stay like this. You see my fingers?
yeah.
But it doesn't. It spins so that my thumb is always facing the planet. That's the moon spinning.
Okay, but we never see the backside of the moon.
No, because it's called tidally locked. It spins at the same rate as its orbital period. So its orbital rotation and its rotation around its own axis are the same period. That's why it's like a wheel on a wheel. You know, if a wheel slips, then it doesn't rotate. But if there's enough friction, the wheel turns as it moves on the bigger wheel.
No, but I get that. But you would be saying that the size would be in comparison to the rotation of the object. The moon is no.
I don't think. I think it may have more to do with the size of the minimum, because we do know that in vortices, the material always spins around the center. So it could be that as the material aggregated onto, as it came together, the whole planetary core, just the action of it coming together caused, and the increase of the gravitational field as it came together, caused the planet to start rotating.
Okay, I'll meditate on this because because we can see the other moons around the other planets, and because the planet is much larger than the moon, that they see the moon rotating because the rotation.
Yeah, but don't forget, Venus has a very slow rotational period,
but Venus has no moons either, does it?
And it has no moons.
Yeah.
Neither does Mercury.
Well, Mercury, I think I'm reading a book right now that Mercury is a little oddball itself.
It has the densest cores of all the inner planets.
Yeah, and
and that is, I haven't written about this before, but that's very telling, because you would expect the densest planets to be closest to the sun, because of the way gravity is. So you would get the densest planet. So Mercury would be likely to be the densest planet because it is the closest. And wherever the planets end up has something to do with the density of that planet. Just like you would have the nebula clouds that the sun produces from its solar wind, and the heaviest elements will be in the inner cloud, and the lightest elements would be in the outer nebula cloud.
I'll tell you, we still don't know everything, but it's very odd. And actually, Mercury is also one of those odd planets that it seems that its outer shell, its mantle, it recycles it very often, apparently. Mm-hmm. And then you have the example of the Titan, Europa, around Jupiter, that these have volcano activity that is going on these moons.
Yeah, because they have cores, and there's energy being generated in the core. And so there's always heat and energy coming from the interior of a planet or a moon.
And that's caused by gravity, right? that the reason why they would be
It is
heating up?
caused by gravity. The core actually, as long as the core has energy and generates energy, the object has heat on the inside. It produces an electric field on the outside. It has a positively charged core. It has an outer negative layer. And it generates an electric field, a strong electric field, which will go with the size of the core. But once that energy is gone, the object loses the ability to generate a gravitational field. It will still have a little bit, but it will be very weak. And it would lose its outer electric field as well. That's what happens with stars. That's why they die. They're not able to emit light anymore. And, because they're not able to generate that energy anymore. And that energy basically is photons. It means that photons are coming out from the core of the object and are feeding all the layers of the object.
Do you think our moon is hollow?
Probably.
That's what I keep thinking. I mean,
I think so. I think most planets may. I think maybe all planets are hollow.
Well, there very well may be on that.
Yeah.
I'm convinced that it is hollow. Gene Cernan certainly told me that he was absolutely convinced that it is in fact hollow. He walked on it, supposedly. So,
How did he know it was hollow? Did he?
Well, they did an experiment with Apollo 14 that set NASA all into a tizzy. Was that they sent basically it was an explosive charge, and they had put sensors to hear the ding, that's what it was supposed to do. And as Gene Cernan, he said the damn thing, he said it took it 3 hours to do return signal. And he said that can only happen. He said, number one, he said it was impossible. They didn't think it could actually happen, but it did. So, yeah.
That's interesting.
And like I said,
that would mean that it's very hollow.
Yeah, he also believed that there were there are others up there. He said, of course, everyone has it. Now, I'm trying to pull up a picture because I wanted to show you, Claudia, from, I believe this was Apollo. And give me 1 second. Of course, when you're looking for it, you never find it. It's like, so I'll just keep on doing the ad lib. But there is a picture I wanted to show you about the moon. And then I wanted to get to your other article on the holographic sky, because there have been a lot of people who have been sending in pictures that are seeing a holographic sky. That's the only thing I can. Go ahead. I'm sorry.
Now, I've written some articles about how, that would be possible. Yeah, about, I've seen a lot of evidence that a lot of things are holograms, that a lot of things that we are seeing, like the moon, even the sun at times seems to be holographic.
So
holographic projection.
I'm going to show you this. I just pulled it up so we could see it. So there it is. This is the moon back here, and this is the object that they captured.
Wow. That's interesting.
Yeah, and the reason why they know it is an anomaly, you can actually see the inside of the aircraft as they're snapping the picture.
Oh my.
You see it right here?
Yes.
You can actually see the astronaut sitting in the command module, and this passed in front of the moon.
Oh my.
Now, I contend, Claudia, someone asked, I think it was Carrie, says, does Claudia think that the 1859 Carrington event was caused by Nibiru, or I'm going to add a potential stellar core?
I think so. I think that's very likely. Yeah, it was just after 1859, wasn't it?
Yes, it was
Yes, I think
1859.
so. I think it definitely was. I mean, I can't be absolutely sure, but I know the stellar core, there were signs the stellar cores were here already. And I've seen plenty of evidence to suggest that they are actually what provokes the sun into having these solar flares and these CMEs.
Well, I think that this is just one of the partial evidence. I also,
Yeah, that definitely looks like a hologram kind of thing. It doesn't look
it's,
normal at all.
it
And
does not.
that's from the Apollo days.
Yes, ma'am.
Wow.
Now, I also pulled up some archival as well on what we have seen here of late. And let me pull this up because I think that there's more evidence of this, Claudia, than what we see. So give me 1 second. And can you see that?
No, you're not
No.
sure.
Where am I?
The screen.
Yes. Why can't I see myself?
Mm-hmm.
Well, that presents a problem. There we go. And I still can't see myself.
Oh my goodness.
Yes, well,
Now I can see you.
yeah, I just can't see you. Let's see.
Really?
There we go. Now I can see
Oh.
myself. That was bizarre. It's like, well, where did I go?
Uh-huh.
Okay, so let me pull this back up again. Now that I know where I'm at. Okay, now I should be able to see that. As he says, okay. So do you see that?
Yes.
So here's that object right there.
Uh-huh.
And I have a number of these.
Oh my goodness. Wow. They look like UFOs.
They're big.
They are huge. It could be a whole lot of objects together, of course, like a debris field, but
It looks like a debris field to me.
yeah, it does.
I don't know if I can actually expand out on these. Yeah, there I can.
Yes.
So there we go, Claudia. Look at
That
that.
definitely does look like a debris field, yes.
Doesn't look at this.
Look at that.
So, and this, by the way, folks, was just last month. I'm contending, Claudia, because here it is again.
Oh, yes.
So let me pull up on this so everyone can see. And I'll pull it down. There we go again.
Yeah.
Same debris field.
Yes.
Am I missing something here?
Well, you are seeing it.
I mean, and it's not just in a stationary orbit. There it is, even closer. Let's get it up. Look at the debris field.
That, yes. My goodness.
That's a debris field, I contend.
Definitely, yeah.
Now, I don't know what the object is, but here it is over here. Let's pull it up again. There's the debris field.
Yeah. My goodness.
Here it is again. The same debris field. And you look at the ratio and the perspective. This is what you would expect if it was an object out there. I'm contending there is potentially something out there that we get the same thing here. You can say this was May 3rd. Our object, there it is.
My goodness, look at that.
Again,
that's amazing.
This object came through. Look at that. Let me try to pull it there. Look at that. Amazing. Do you see the debris field, Claudia?
Yeah.
It's there every time, no matter what perspective it's coming back on. So I don't know. What do you think?
Well, it looks like a debris field. It's huge.
It is. It's very large.
Yeah.
So I don't know.
Well, I actually think that most of the debris that's around the sun we're not seeing because they sort of mopping up the images.
And they do that. They
Yeah.
do. They
And
sanitize them.
they sanitize them, and they may even add things to them.
Yeah. Well, I just had that in my files, and I wanted to show you that this, whatever it is, and it's making it looks to me to be coming, I don't know, this sounds ridiculous, but it looks to me like it's coming in closer as though you were spinning a vortex.
Yeah.
But that, Claudia, looked like to me to be a debris field.
Yes, it did.
So we have a couple more of your papers, Claudia.
Uh-huh.
And I'd like to get into the holographic sky generation system. This was an interesting paper.
Okay. Yes, so I started with your picture. You actually sent me this picture.
Yes.
And you can see how the pattern repeats itself. It's like the sky's become a TV screen.
That's a very good description of it.
So this is basically a holographic, they made a holographic screen out of the sky. And so I was trying to figure out how they were doing this. And I said, well, you see two main colors here, magenta and blue. So that would mean they're possibly using a magenta laser and a blue laser. A magenta laser is actually a combination of red and blue. But you can combine the two specific colors into one laser, or use two different lasers and combine them. But that's basically the two colors that we have here, just combined or producing this pattern.
It's trippy.
Yeah, it's amazing. It's amazing. But clearly, it's a hologram. You can see the sky. The whole sky is a hologram. Not the whole sky.
I don't know how that's natural.
I'm not saying they will do the whole sky. But this is a big section of sky.
Yes.
So I was trying to figure out how they would do it. And so you get two types of holograms. And basically, you produce a photographic plate. It's almost like producing a photograph. But there are two kinds. There's the transmission and the reflection. The reflection holographic plate only produces a virtual image, as if it's a mirror and we're seeing an image behind the mirror. So this is not the kind that we have here. We must have a real image in front of the photographic plate. And that is produced by a transmission photographic plate. Transmission means you shine light through it. It's got holes in it. Like, so let's move up a little bit and I'll show you how it's produced first.
Is it this one here?
Yeah, that's the photographic plate there at the bottom.
Okay.
That becomes the hologram, the transmission hologram. So what you do is you take laser light, you split the beam into two, and then one part of the beam will illuminate the object you're trying to produce a hologram of. And the other beam is called the reference beam. And then the intersection of the two beams and how they intersect produces a recording. It's an interference pattern that is recorded on the photographic plate. And then if we go down, we'll see how that is produced. Then what you do is you take the reference beam and you must shine it on the photographic plate at exactly the same angle that it was shining on it when the photographic plate or the hologram was produced. And then it produces an exact three-dimensional image of that object that you recorded. And it produces two images, one on either side. One will be a virtual image. It will be behind the photographic plate, and the other one will be in front. So if we move down a little bit further, so that's what you do. So the first one is a real image because it's very close to the eye. You see it's in front of the plate.
Okay.
And the second one will be virtual. It'll be behind the plate. So you would get two images, one behind and one in front. And
How interesting. I'm trying to
But
keep
now
up.
holograms can be computer generated. So you don't have to go through the recording procedure. You simply computer generate it as a digital signal. You can then imprint that signal onto the sky itself, because we have a lot of metallic nanoparticles in the sky. So you can actually, through probably sound waves, produce regions of high density and low density of these nanoparticles. And that changes them into a photographic or a hologram plate. And then all you have to do is illuminate it with your laser light. And you have lenses to widen the beams that come from the lasers. And then you'll be able to produce images. Some will be virtual, some will be real images. And usually I think they try to produce a real image of the sun so that it's very close to the eye and it looks as large as possible. But they can produce a virtual image of the sky, which will be above the plate. So it looks like there's blue sky above it. So that's one of the things they can do. They can do anything, because basically they computer generate anything they want.
So I brought a little demonstration, Claudia, and I don't know how this is going to show up on the camera, but we're going to try. So this is Mylar. Okay, now folks, I want to show you something. When I haven't done this on camera, but watch this, Claudia. So when I put...
I think it will be better if you stop sharing, though.
Okay, let's do this. Let's stop
because it will look larger on the screen.
There we go. Yeah, now this will actually be pretty cool. So what I have here, this is Mylar, and as you can see, I can shine a laser through the Mylar, and if I was to put an image, as you said, the plate right here, look how the laser diffuses, which in this case is no image, but you can see what's happening. It diffuses very quickly, and I contend that this is what you can do in the sky with a simulator or other type of device.
Yes.
And here I am pointing the laser now back at the Mylar, and look what happens. I mean, you can begin to see how the light can be diffused. So
yes,
this is a very simple experiment to show, as you were pointing out, how we can take this substance, which has been around and is now even getting more refined, and how we can begin now using lasers and split that light. It falls right into line what you were saying.
Yes, definitely.
So I thought that might be a kind of a cool experiment.
Yeah, that was very interesting. Yeah.
You
can do a lot with lasers, and there's a lot of reasons why they are chemtrailing, why they are infusing those particles into the atmosphere. There are a lot of things that they are doing with them.
Yes, absolutely. And someone was saying that, the laser angle determines the reflectiveness or transparency of it. And it's very true. I mean, I am now reading of that there are governments, and specifically this was, I'll say who it is. It was Saudi Arabia, that is testing images that will literally cover their skies with holographic images. So if they can do that, Claudia, more and more in a regional spot, it's not that hard to see how they could actually have a moving image that could be virtually seen at the same place all around the world. Yeah,
that's right. Yeah, it's amazing what they can do, and obviously they are doing it. I mean, we saw from that photograph what the sky looked like.
They are. Someone said,
and that must be because there was some kind of malfunction, because obviously they're not supposed to show us that kind of a pattern. So there was kind of a malfunction in the signal they were sending to this screen, because, you know, it's not supposed to be that regular so that people notice.
Someone, you know, had asked me, they said, well, how do you look at the sky? And I said, well, how I look at the atmosphere is that it's levels of Raman, you know, what we would call the filament of the sky.
Mm-hmm.
And filaments are just that. They're different layers of energy.
Yeah.
And I don't think that, you know, we have the troposphere, the ionosphere, et cetera, but I contend that within those different spheres, Claudia, that there are yet new spheres that we have not yet come to detect.
Yeah, I think there may be a lot more to our planet than we've been told. I mean, I find more and more things that have been hidden from us about the sun. We've been taught all kinds of theories that are often completely opposite of the way the universe is. It's almost like it's done on purpose, so we never realize what kind of universe we're living in. And I think a lot that we've been taught about our planet is not true either. There's a lot being hidden still.
And I've really been, I'm reading this right now.
Oh, yes, yes.
And I'll tell you, this should be required reading. What do you think of his theory?
Yes, I've heard about it. I think he was the one that first talked about a comet, and that being Venus, and disturbing the order in the solar system.
He contends that Earth was all.
Hello? Hello? Hello, Wayne? Well, it looks like Wayne's gone. I think since we are out of time, maybe we should just finish here. So I'll just say goodbye.